Today I will be discussing the differences between science projects and engineering projects. Both types of projects are accepted at the STEM fair. Science projects follow the scientific process, while engineering projects follow the engineering design process. While both processes are similar, there are a few key differences. I will be using two of my previous projects as examples to show the differences. The first project is a science project, where I determined which launch angle for a ballista made the projectile travel the farthest. The second is an engineering project, where I modified a remote-controlled car so that it stopped when it sensed an object in front of it. When starting a science project, you create a problem statement and hypothesis. The problem statement is a question that can be answered by collecting data. It should put the problem in context, show the relevance of the project, and set the objectives of the research. Based on your background research, you then develop a hypothesis, which is a prediction of the answer to your question. For my science project, my statement of problem was what should the launch angle of a ballista be for its projectile to travel the farthest distance. My hypothesis was that a ballista launch angle of 45 degrees will result in the farthest distance traveled by the projectile. For engineering projects, you create a purpose statement and design objective instead. The purpose statement explains why what you're building is important. Why is your design needed? What problem are you trying to solve? The design objective explains what you will be attempting to build or design. It includes measurable metrics that demonstrate how each iteration of your design is an improvement over the previous design. Include when you know that your design has met the objective. For my engineering project, my statement of purpose was that every day the most dangerous thing a person does is ride in a car. Thousands of car crashes happen and some are fatal. Most of these accidents happen because the drivers did not stop on time. The majority of car accidents can be prevented if cars automatically stop before it hits another object. My design objective was to design, build, and code a remote-controlled car that automatically stops when it senses an object in front of it. The automatic stopping should engage when it senses an object that is half as tall and a fourth as wide as the car. The next step in a science project is to create a controlled experiment. In this experiment, you have one independent variable that is changed at a time, and a dependent variable that you measure. For my project, the independent variable was the launch angle, and the dependent variable was the distance that the projectile traveled. For each trial, make sure you have a large enough sample size. My sample size was the number of projectiles I launched at each angle. In this case, I launched 10 projectiles for each angle. For an engineering project, you start by building a prototype of your design. As you are building your design, you will need to troubleshoot and refine your design. It is important to show how each subsequent design is an improvement over the previous design and moves closer to the design objective. One of my challenges was determining how to get the car to stop. I did this by cutting power to the car. However, when power was cut, the car continued to coast forward. My solution was to have the wheels turn backwards for a short amount of time to counter the forward momentum and stop the car. Finally, in a science project, you analyze your data and develop a conclusion. Your conclusion will either support or not support your hypothesis. It is totally okay if your hypothesis is incorrect. I discovered that my data did indeed support my hypothesis, that 45 degrees allowed the projectile to travel the farthest. However, I found that angles a little bit less than 45 degrees went farther than angles a little bit more than 45 degrees. The final step in an engineering project is to show your design's functionality. You need to demonstrate that your design meets your design objective. To test my design, I tested my car against different height walls and different width cylinders to imitate situations that a car might encounter in real life. Thank you for listening, and I'll see you at the fair.